Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna.
And I'm Avery. It's Monday, February 2nd, 2026. And we've got a fantastic lineup of stories today, exploring everything from SpaceX's audacious satellite plans to ancient star maps hidden for centuries.
That's right, Avery. Today, we're diving into SpaceX's jaw-dropping proposal to launch up to 1 million solar-powered satellites, a remarkable archaeological discovery revealing Hipparchus's lost star catalog, and China's ambitious solar monitoring mission heading to a unique point in space.
We'll also be discussing a giant star that fooled astronomers worldwide, Time Magazine's special tribute to the Artemis II crew, and remembering Gladys West, a hidden figure who helps shape GPS technology. It's going to be an incredible journey through space history, present, and future.
So settle in and let's explore the cosmos together.
We're starting with what might be the most ambitious satellite constellation proposal ever conceived. SpaceX has filed with the Federal Communications Commission seeking approval to launch up to 1 million solar-powered satellites that would function as data centers for artificial intelligence.
1 million satellites, Avery. That's absolutely staggering. To put that in perspective, there are currently around 15,000 man-made satellites orbiting Earth, according to the European Space Agency. SpaceX is essentially proposing to increase that number by several orders of magnitude.
The scale is mind-boggling, Anna, and SpaceX isn't just framing this as a commercial venture. Their filing describes these satellites as the most efficient way to meet accelerating demand for AI computing power. But they go even further. They're calling it a first step towards becoming a Kardashev Type II civilization, one that can harness the sun's full power.
That's quite the vision. For our listeners who might not be familiar, the Kardashev scale is a method of measuring a civilization's technological advancement based on energy consumption. A Type II civilization would be able to harness all the energy output of its star. But let's talk practicalities here. The Verge has pointed out that the 1 million satellite number is unlikely to be approved outright and is probably a starting point for negotiation.
Exactly. The FCC recently gave SpaceX permission to launch an additional 7,575 Starlink satellites, but deferred authorization on the remaining 14,988 satellites proposed. So there's clearly regulatory caution about satellite proliferation. And there are very real concerns about space debris and light pollution that come with such massive constellations.
The timing is also interesting. This filing comes as Amazon is seeking an FCC extension on a deadline to have more than 1,600 satellites in orbit, citing a lack of available rockets. Meanwhile, SpaceX is reportedly considering a merger with two of Elon Musk's other companies, Tesla and xAI, ahead of going public.
It really shows how the commercial space sector is evolving, Anna. What was once the domain of governments is increasingly being driven by private companies with enormous ambitions. Whether SpaceX gets approval for anything close to 1 million satellites remains to be seen, but it certainly signals where they think the future is headed.
It's fascinating to think about, but we'll have to see how regulators balance innovation with the very real concerns about our orbital environment. Now, let's move from the future to the distant past.
From cutting-edge satellite technology, we're traveling back more than 2,000 years to rediscover one of astronomy's greatest lost treasures. Scientists have successfully recovered fragments of the world's earliest star catalog, created by the ancient Greek astronomer Hipparchus from a 1,500-year-old manuscript.
This is absolutely remarkable, Avery. Hipparchus is widely considered the father of astronomy. He figured out how equinoxes shift, created a magnitude scale to rank star brightness, and tracked planetary motion, all more than 2,000 years ago without any telescopes. But his actual star catalog had vanished from history until now.
The manuscript is what's called a palimpsest, which means it's parchment that was wiped clean and reused. In this case, Hipparchus's original Greek text was erased and overwritten with Syriac religious writings of Saint John Climacus. The original work was literally buried under 6 layers of ink.
So how did researchers manage to read text that was intentionally erased centuries ago? They used some pretty sophisticated technology. A team led by Victor Giesenberg from Sorbonne University used X-ray technology at the SALC National Accelerator Laboratory to scan 11 pages of the manuscript.
The key was that Hipparchus' original ink had a different chemical composition than the later religious texts. The ancient ink was rich in calcium, which showed up clearly under X-ray scanning. They used extremely short X-ray pulses, each just 10 milliseconds long, focused on areas no wider than a human hair.
And what they found is remarkable. These aren't just historical curiosities. The star positions Hipparchus recorded are incredibly accurate for naked eye observations. As Giesenberg said, the coordinates they're finding are incredibly accurate for something done with the naked eye. This gives us a window into how ancient people understood and mapped the night sky.
It's also a testament to early scientific thinking. Hipparchus was working without any optical instruments, yet he was able to create precise astronomical measurements that laid the foundation for future astronomers. This discovery, published in the Journal for the History of Astronomy, helps us answer fundamental questions about the birth of science itself.
And the manuscript, now held at the Museum of the Bible in Washington, D.C., is so delicate it had to be hand-carried in climate-controlled boxes to the laboratory. It's wonderful that modern technology can help us recover these ancient insights. Speaking of technology and new vantage points, let's turn to China's upcoming solar mission.
China is making major strides in solar exploration, with plans to launch its first-ever solar probe to the Sun-Earth L5 point. The satellite, called Xihe 2, is scheduled to launch between 2028 and 2029, and it will provide a unique perspective on solar activity that we've never had before.
For our listeners who might not be familiar, the L5 point, or Lagrange point 5, is one of 5 special locations in space where the gravitational forces of the Earth and Sun balance out. It's about 150 million kilometers from Earth, and spacecraft positioned there require minimal fuel to maintain their orbit because they're in a stable gravitational equilibrium.
Exactly, Anna. And L5 provides a direct, unobstructed view of the Sun without Earth's atmosphere getting in the way. This makes it ideal for capturing detailed data on solar magnetic fields, flares, and eruptions. Xihe 2 will be the first artificial probe ever stationed at this location.
The mission has some impressive capabilities. Xihe 2 is equipped with cutting-edge technology designed for high-precision magnetic field detection. This will help reveal the intricate dynamics of solar eruptions. But here's what's really exciting. The mission aims to predict solar activity up to 5 days in advance.
That's a game changer for space weather forecasting. Solar flares and coronal mass ejections can have profound effects on Earth's magnetic field and satellite systems. We've seen how geomagnetic storms can disrupt communication networks, GPS systems, and even power grids. Having 5 days advance warning could help protect critical infrastructure.
It's worth noting this builds on China's previous solar mission. In 2021, China launched Xihe, their first solar exploration satellite, which captured solar H-alpha spectral imaging from low Earth orbit. Xihe 2 represents a much more ambitious leap, heading to a distant and challenging location.
The mission is a collaborative effort between Nanjing University, the China Meteorological Administration, and the Shanghai Academy of Spaceflight Technology. It really demonstrates China's growing leadership in space exploration and their commitment to understanding space weather.
And as we become increasingly reliant on space-based technologies, understanding and predicting solar activity becomes more crucial than ever. This mission could significantly improve our ability to protect satellites, astronauts, and infrastructure on Earth. Now, let's turn to a mystery that had astronomers scratching their heads.
Here's a stellar detective story for you. Astronomers thought they were watching a massive star called WOH-G64 undergo its death throes, possibly even transforming into a rare yellow hypergiant before going supernova. Turns out, they were completely wrong.
This is such a great example of how science works, Avery. WOH-G64 is located in the Large Magellanic Cloud and is one of the most luminous, dust-enshrouded red supergiants in its galaxy. In recent years, astronomers observed unusual dimming and changing spectral features that suggested the star was entering an extremely rare and unstable phase.
In 2024, the appearance of a new dust cloud around the star seemed to confirm that something dramatic was happening. Many researchers thought they were witnessing a massive star in its final moments. But fresh observations from a team led by Dr. Jocko van Loon at Kiel University revealed a completely different story.
Between November 2024 and December 2025, the team used the Southern African Large Telescope to collect detailed optical spectra of WO G64. But they found contradicted all the previous assumptions. Instead of the temperature increase you'd expect in a yellow hypergiant, they found strong absorption bands from titanium oxide molecules.
And here's why that matters. Titanium oxide molecules can't survive in the hotter environment of a yellow hypergiant. That meant WO G64 hadn't undergone the suspected transformation at all. Something else was causing all those puzzling observations.
The answer turned out to be a companion star. WOH64 is actually part of a binary system. A smaller, hotter companion star orbits the red supergiant and periodically interacts with its extended atmosphere. As Van Loon explained, the atmosphere of the red supergiant is being stretched out by the approach of the companion star, but it hasn't been stripped altogether.
So nearly every major indicator that astronomers had interpreted as signs of impending stellar death, the fading light, the spectral shifts, the dust formation, was actually caused by this companion star. Some of the disrupted material even appears to form a disk around the hot companion, which contributed to those strange spectral emissions.
Van Loon described it beautifully. We're essentially witnessing a phoenix rising from the ashes. It's not that WOH G64 won't eventually go supernova, it will. But that event isn't imminent, despite what all the evidence seemed to suggest. This discovery highlights how binary interactions can perfectly mimic the hallmarks of a dying star.
It's a humbling reminder that the universe still has plenty of surprises for us. Careful follow-up observations with attention to dust obscuration revealed that earlier spectral signals were misleading. Now, let's shift from stellar mysteries to human achievements as Time magazine celebrates an historic moment.
As NASA's Artemis II mission sits poised on Launch Pad 39B at Kennedy Space Center, Time magazine has honored the crew with a special commemorative cover issue that draws powerful parallels to one of history's most pivotal space missions.
The cover features the 4 Artemis II astronauts, Reed Wiseman, Jeremy Hansen, Victor Glover, and Christina Koch, who are scheduled to launch as early as February 8th for a 10-day lunar flyby mission. The article accompanying it was written by Jeffrey Kluger, the best-selling author known for Apollo 13 and the Apollo murders.
What's particularly poignant is the comparison Kluger draws to Apollo 8, which orbited the moon in December 1968. That was a year of tremendous turmoil in the United States and around the world, and Apollo 8's Christmas Eve broadcast from lunar orbit provided a moment of unity and inspiration that transcended borders and politics.
As Kluger writes in the article, not every mission touches the collective soul, but some do. Apollo 8, Apollo 11, Apollo 13. These were less American experiences than global dramas, global triumphs, global joys. And he suggests Artemis II could work similar magic today.
The mission itself will push human spaceflight to new limits. Artemis II's trajectory will take the crew 4,700 miles beyond the far side of the moon, farther than our species has ever traveled. That will break the old record of 158 miles past the moon, which was held by the Apollo 13 astronauts during that dramatic 1970 mission.
NASA Administrator Jared Isaacman posted side-by-side Time magazine covers from 1968 and 2026 on social media, noting that 58 years after Apollo 8's historic trip, NASA is heading back. He emphasized that through the Artemis campaign, the agency aims to maintain American leadership in space, land astronauts on the moon, and establish a lunar base all before the end of 2028.
What strikes me about both Apollo 8 and Artemis 2 is their role in opening new chapters. Apollo 8 proved humans could safely journey to the moon and return, paving the way for Apollo 11's landing. Artemis 2 is similarly demonstrating the capabilities that will enable Artemis 3 to put humans back on the lunar surface.
And as Kluger points out, the mission represents not just a technological achievement, but a significant edge in any space race with China, while also offering the kind of public uplift that spaceflight has uniquely been able to provide since the 1960s. It's a moment when 4 people serve as emissaries for the 8.3 billion of us who remain earthbound.
With the wet dress rehearsal happening right now and launch potentially just days away, this Time magazine issue captures what could be one of 2026's most inspiring moments. And speaking of inspiration, we need to remember someone who made a profound but often overlooked contribution to how we navigate our world.
We're closing today's show with a remembrance of Dr. Gladys West, who passed away Saturday at the age of 95. West was one of the hidden figures whose work fundamentally shaped modern GPS technology, yet her contributions went largely unrecognized until recently.
Gladys West's story is one of extraordinary perseverance and achievement in the face of significant obstacles. She was born on October 27, 1930, in rural Sutherland, Virginia, south of Richmond. Her parents had a small farm, and most of the region's population were tenant farmers, known as sharecroppers.
She initially expected her future would lead to farm work or a job at the tobacco processing plant where her mother worked. But she excelled academically, becoming valedictorian of her high school graduating class. She earned a full scholarship to Virginia State College, which was a historically Black institution, and went on to earn both her bachelor's and master's degrees in mathematics.
This was during the Jim Crow era of racial segregation, Avery. After graduating in 1955, the same year President Eisenhower banned racial discrimination in federal hiring, West began working at what was then called the Naval Proving Ground in Dahlgren, Virginia. She told NPR that there were 3 other Black professionals there, and they tried to treat the leaders with respect, while hoping for the same treatment in return.
West stayed at Dahlgren for 42 years, and her contributions were remarkable. In the 1960s, she participated in a study showing that Pluto's motion is regular compared with Neptune. But her most significant work came in the 1970s and 80s, when she helped develop the foundational mathematics for GPS.
What's fascinating is the complexity of what she accomplished. West used intricate algorithms to account for variations in gravitational, tidal, and other forces that distort Earth's shape. She programmed the IBM 7030 computer, also known as Stretch, to deliver increasingly refined calculations for an extremely accurate model of Earth's shape, specifically optimized for what ultimately became the GPS orbit used by satellite.
Her work essentially created the mathematical framework that allows GPS to function accurately. Today, there are about 4 billion GPS users worldwide, according to Lockheed Martin. Yet, when asked about using GPS herself, West told an NPR affiliate in 2020 that she used it on a minimal basis. She preferred maps.
West's career wasn't widely recognized until the 2016 publication of Margot Lee Shetterly's book, Hidden Figures, and the Hollywood film based on it. After that, the accolades came quickly. She was inducted into the Air Force Space and Missile Pioneers Hall of Fame in 2018, received the Webby Lifetime Achievement Award in 2021, and was honored with the Prince Philip Medal by the UK's Royal Academy of Engineering.
She was predeceased last year by her husband of 57 years, Ira, whom she met at the Naval Proving Ground. The couple had 3 children and 7 grandchildren. Her family announced that she passed peacefully alongside loved ones.
Gladys West's story reminds us that some of the most important scientific contributions come from unexpected places and from people who had to overcome tremendous barriers. From a childhood in rural Virginia during segregation to reshaping how the entire world navigates, her legacy touches billions of lives every single day.
Every time someone uses GPS to find directions, track a delivery, or navigate by sea or air, they're benefiting from the mathematical foundations Gladys West helped establish. It's a powerful reminder that science is built by people from all backgrounds, and that we should celebrate those contributions while the pioneers are still with us.
And that wraps up today's episode of Astronomy Daily. We've journeyed from SpaceX's ambitious satellite plans to ancient star maps, from solar observatories at special points in space to stellar mysteries solved, from upcoming lunar missions to the legacy of a GPS pioneer.
It's been quite a tour through the cosmos, Anna. As always, we're grateful you joined us for this exploration of space and astronomy news. If you enjoyed today's episode, please subscribe to Astronomy Daily on your favorite podcast platform.
You can also find us on social media. We're at Astro Daily Pod on Twitter, Facebook, Instagram, TikTok, YouTube, and Tumblr. Visit our website at astronomydaily.io for more space news and to explore our archive of past episodes.
I'm Avery.
And I'm Anna. Thank you for listening, and we'll see you tomorrow with more news from the final frontier.
Clear skies.
Astronomy Daily.